This is the real Tom Rose. This is an interesting geometry problem here. Square is inscribed in a circle. The area of the circle is pi. What's the area of the square? So we need to somehow connect the circle and the square. The way I like to connect it is here. If we knew this distance, that would tell us stuff about both the circle and the square. And we can calculate that for both the circle and the square, right? That's half the diagonal of the square. And it's also the radius of the circle. So we have the area of the circle. Calculate area of a circle with pi r squared, but they tell us the area is pi. So pi equals pi r squared, which means 1 equals r squared, which means r equals 1. So the radius of the circle is 1, which means the diagonal of a square is 2, right? Because we have to double it. You can say the diagonal of the square is the same as the diameter of the circle, which is twice the radius. So if you have a square and you know the diagonal, this is a 45, 45, 90-degree triangle, right? So you could also use the Pythagorean theorem for this, but you really want to have this memorized. The ratio of these sides are, let's put this in a different color, are 1 and root 2. Or you could think of it as, this is the same ratio, but I'm just writing it differently, is you could think of this as 1 and root 2 over 2. That's the same ratio, but just flipped, so you have the 1 in different places. I have them both memorized, which is useful depending on what direction you have to go. So let's use the green one. So if I'm saying the diagonal is 2, right, and if the diagonal is 2, then the side is that multiplied by root 2 over 2. So the side is 2 times root 2 over 2, which equals root 2. The side has length root 2. What do we want? We want the area of the square. Area of the square is equal to side squared, which is equal to root 2 squared, which is equal to 2.